11.7 is called the series testing strategy. So it's a really, really nice section where we're not going to learn any new tests. We've learned all the tests. I believe there are 10 of them total. This is a chance to just sit and reflect on all of them together. We had a similar section back in our very first chapter on integration. We had like an integration strategy section where we just got to sort of be presented with different integrals from all different styles. And, the point was to be able to distinguish visually which type of integral technique fit which integral. So, same idea here. We're just taking some time to pause, reflect. But now, I think we had about 4 integration techniques. Where here we've got like 10 tests. So there's a little bit more going on, but it's also easier to identify some of them. So what we're going to do in this video, we're just going to go through all the tests, and I'm going to tell you, point out like what to look for, which kind with each kind of test, each of the 10. So it's probably something you've been doing already. It's probably something that, at least for the most part, it's really just kind of goes along with learning a new test. Like, well, it takes this certain form, and this is the test if it takes that form. So that's kind of the ways to identify it. But then there's maybe some other things that are not so obvious. So this section is just going to be the one video. We're not going to do any examples together. I'm just going to give you the strategy, and then it will be up to you guys to tackle that homework. I also have, I'm going to post what would have been our quiz on this section. I'm going to post that just under this video. So I recommend after watching this video, go there and take a look at what would have been our quiz. And I'm also going to post an answer key to that. I'm not sure when. I might post the answer key at the same time. So it's kind of up to you to take the mock quiz on your own, and then when you're done and you're confident, then look at the answers that I'll post beneath. Okay, really, and the quiz is just identifying which test to use. So it's not going to be do all these 10 different um, you know convergence, divergence things, all the details, just which test to use. Okay, so let's get to the strategy. I'm not going to go in order necessarily, although it's mostly in order. I'm going to recommend begin with thinking about the divergence test. So whenever you're presented with a series, if it's not absolutely immediately obvious what to do, think about the divergence test. Why is that? Because the divergence test, if it works, you're done, and it's really fast. So what is it? What was the divergence test again? All we got to do is take the limit as n approaches infinity for our nth term. If we get, oh, and it looks like I need to update this. If we get something that is not 0, if it does not equal 0, then right then we know it diverges. Done. Right? 19 out of 20 series, that limit does go to 0, in which case we need to apply a different test. But if it does not equal 0, we're done. So a great way to start off and just rule that out. It would really be a tragedy to spend an hour on a series testing it in all different ways, and you never realized you could have just done divergence test. So that's number okay. Second one, now we'll go with the geoseries, and that was the first one that we learned, the geoseries test. So if you're given a series that looks like this, or maybe there's some algebra to do first, there may be algebra to rewrite the series to make it look this way. There may be some series algebra to make it start at 0. We saw things like that. Like be sure starts at n equals 0. Okay. Then you can use the geometric series test. And then I won't go through all the details of every test, but it's all about the value of r, right? If r is less than 1, then you know it converges. Okay, next up, I'm going to jump ahead to the p-series. P-series is a very similar field to the geoseries. It looks like 1 over n to the p. It could start anywhere. Doesn't have to start at 1. 1 over n to the p, and all you got to do is look at the value of p, and if p is greater than 1, then you know that that converges, and you're done. There's nothing else. Again, there might be some algebra to do to rewrite it this way. All right. Next up is the comparison tests. And we learn the comparison tests after we learn geo and p-series. Typically, when we compare, we're comparing to one of these styles, right? These really well-known forms. Maybe we can compare our complicated series by removing some of the parts to make it look like a geo or to make it look like a p-series. Really what we're after, and the way I presented it in that section, we're after direct comparison test, right? So if we make the series bigger, we're hoping that bigger one converges, right? So that the original will converge. If we make the series smaller, we're hoping the smaller one diverges so that the original then also diverges. So really our aim is DCT, direct comparison test. But sometimes the logic doesn't work. Sometimes we make a series bigger, but then the bigger one diverges. And we don't know anything about the original, the smaller one. Or maybe we make it smaller, but then the smaller one converges. And we don't know anything about the original, the bigger one. So if we get that backwards kind of logic, in other words, if the direct comparison test doesn't work logically, then I recommend just think, hey, the fallback is always the limit comparison test, LCT. Certainly, limit comparison test is its own test in its own right, but typically we see it as a backup plan to the DCT. Okay. Number 5. This is an easy one to identify, right? The alternating series test. And I list it as number 5. It's almost like I'm giving like a flow chart. Certainly you might recognize this immediately, and you just, right, you don't have to worry about, oh, is it a geo? Well, no, like you're not even thinking that. It's clear to you right away that it's an alternating series. And so there's these two conditions, right? You have to check that the non-alternating part, the AN, we call it, that limit goes to 0, and that the terms are monotonically decreasing. Okay, and we obviously talked about all those things. So if and did lots of examples. So if both of those happen, then it converges. You might think, well, alternating series tests can only show that a series converges. If one of them fails, then what do we do? And well, that came up in the conversation in that section. If number 1 fails, then, oh, our limit did not equal 0. So then we can immediately say that the series diverges by the divergence test, which is a really, really nifty backup plan in case number 1 fails. You might think, well, what if number 2 fails? Well, that for the series that we're looking at, that just won't happen. If 1 fails, 2 is always going to follow. And we talked about that then as well. You might think, why do we need number 2? Because we do. Okay. I won't hash that all out again. Okay, so that's the first 5 tests. Actually 6. I'm thinking of these as like one test in this list, but obviously they're 2 tests, DCT, LCT. So that's 6 tests right there. And then we come to the most recent test, ratio test. And the next will be root. I'm skipping ahead. So number 6, ratio test. Here's what to look for. And this may be something you picked up on already. We didn't see a whole lot of factorials before we got into the ratio test. And then we saw them everywhere. And they're really cool to simplify, right? We can set up the ratios of the nth term and the n plus 1th term, right? So when we see a factorial, we're really thinking this is probably going to be a ratio test because factorials simplify so well in the ratio test. Also, constants raised to the nth power simplify really well when we set up those ratios. So if you see either of those, that should immediately like set off, the red light, whatever it is. That ratio. This is probably going to be a ratio test. Okay. Then it's ratio test buddy, the root test. And this one, it may be even easier to identify, and we don't see it nearly as often as ratio test, um, because it's a lot more clear when this happens, right? So when all the terms are raised to the nth power, well, then you want to take an nth root, and all those nth powers are gone, and you just looking at what's left over, right? And you're, yeah. So root test, everything to the nth power. Hey, maybe take an nth root of it as part of the root test would help things out a lot. Well, what was left? Because that was the end of the chapter. So there's a couple that we skipped. So back even in 11.2 was the telescoping series. Telescoping series, it's kind of its own sort of a thing. You don't see it. There's no comparisons really with telescoping series. There's not like this kind of extra stuff. Like it doesn't combine, it doesn't play well with others, right? It doesn't combine well with others. So the telescoping series, one thing, it may require partial fractions to get started. It's always going to be two terms being subtracted. So, one fraction minus another fraction. And it might take partial fractions for that to be clear that that's what's going on. The approach to telescoping series is very different than any other test, because you just look at the nth partial sum, right? And then you see how the cancellation works, and you take the limit of the nth partial sum. So technically it's not even really a test. You would just say something is a telescoping series, and then you use the limit as n approaches infinity for the nth partial sum, which is kind of like the original way we tested any series for convergence. Okay, so telescoping series, we'll tack that on at the end. And there's one more I haven't mentioned yet, because it is the biggest pain out of all the tests, is the integral test. So what might tip you off? I didn't write anything yet, but now something comes to mind. So the integral test, first you have to satisfy those three conditions, right? That your function f of x, the function equivalent of your nth term, is positive, continuous, and decreasing for all the appropriate x values. So that's kind of a hassle to go through all those. And then you begin the integral. You can apply the integral test. Can f of x be integrated, right? So f of x is I just said it, but it's the function equivalent of your series, your nth term. And just, you're asking yourself, if that was a function that I was looking at, could I integrate that, right? Could I use a u substitution? Could I use partial fractions? Could I use partial fractions might even get back to here. Could I use integration by parts? I think is what I was thinking of. And if you can, I would encourage you think about all the other tests first, just because this one takes so long. And this is like your last resort. If you can identify that that can be integrated, well, it might very well be the integral test. And that's it. That's the section up to the chapter up to this point. Again, I stop at number 9. There are really 10 tests because I consider DCT and LCT as the same one, or as one unit. Okay, the last thing I wanted to mention here, of course, now when we start to, we're mixing all of these tests together in your homework section, and on your test, it's going to be that way, right? It's going to say just converge or diverge, and you're going to have parts A through G or something, and you're not going to know what test to use where. You're just going to be trial and error. There's a lot of critical thinking going on. And that takes things to a whole other level. So this is my diagram, just kind of like my analogy for problem solving. Okay. This doesn't go for this chapter or even this class. I mean, this just goes for any kind of problem solving in life, in your careers, in day-to-day living, and working with other people and whatever. Okay, so I've got a tree, right? Here's the ground, and the tree is growing up. It's this big, strong tree, right? These big, thick branches, and that was my best drawing. Okay, so out here someplace, I've drawn a fruit. It looks like a little apple, maybe. Um, so the fruit, to reach that fruit, so you're standing here on the ground, let's say, I don't know, right? That's a big tree. So that's a big apple. So the goal is to climb this tree and reach that fruit, right? If you can reach the fruit, then you've shown that the series converges or diverges, whatever it is. But who knows what kind of a web of a maze or puzzle you're going to have to use to successfully climb this tree to the point where you're asked, right? So the fruit is the goal. Okay. The actual climbing of the tree is your procedure. So we do all these example problems, right? And we know we need to know all the rules for all the tests when something means it converges or diverges, right? And a lot of those rules to the different tests are very similar, and it's easy to mix them up. So all that goes under procedure, that I know what the tests are, I know what the requirements for each test are, and I'm able to execute that. Okay. And a lot of people stop there. They're like, "Hey, let's do this homework problem, let's do that homework problem." We're looking for, that's what lecture looks like. We're looking for procedure. What is the procedure to reach some given fruit? But obviously that can't be it, because if all we talk about is procedure, then maybe you know how to get to the fruit on this branch or on this branch, but as soon as we say, well, now how do you get here? Like, oh, well, I haven't learned the procedure to make it that high, and well, you're going to have to figure that out. So there's something going on beneath the surface, the ground level, right? There's something beneath any tree, and especially a big, thick, tall tree. There's something underneath that's sustaining that tree, right? It's the root system. The root system is more voluminous than the branches, or sometimes even the entire tree itself. The root system, and here's my picture of it. The root system has to be massive to support that tree. If the root system is weak, then that tree's going to topple over, and if someone goes to climb that tree, they're going to fall, and that's going to be a bad situation. Okay, so that's my analogy. So what do the roots represent? That's the critical thinking. So this sort of thing, it's underground, right? It's unseen, but it's implied. And any time we practice a procedure, we're really hinting at the critical thinking that must have been going on underground. So we talk about procedure, but in the talking and in the explaining, we're giving hints to the critical thinking. And really, this whole explanation of all the things that we are looking for, right? This is critical thinking, right? Going through a list, synthesizing. Okay, so that's what I've got for you guys. No examples. There's just a few homework questions, maybe 4, 5, 6. I forget how many, to try this out on, and then take a look at that mock quiz where you just name which series is appropriate in which situation. And then when you're done with that, the answer key is there as well. Good luck to you guys. Of course, any questions, bring them to our Zoom session. See you there.